When we talk about availability, we saw that a network could go unavailable or it could be restored. What is the factor that makes a network unavailable or it brings out the issue of restoration? Here in this module, we are going to look at what are disasters that make a network unavailable and what are the means through which network recovery is possible. So we'd look at a disaster recovery scenario and we'd look at the redundancy that helps us to recover. We'd also conclude with the allocation model for redundancy that provides us high availability. In the wake of disaster, this quote provides us great motivation to prepare ourselves. It's a Latin proverb that says, Amat Victoria Curam, and it says, victory loves preparation. So disaster recovery is only possible if we are well prepared. There's a paper published in 2004 titled Allocating Redundancy to Critical Information Technology Functions Disaster Recovery. This paper addresses a fundamental question. The question is how to allocate resources as redundant for the availability of IT functions such that the concept of survivability, that is, these IT functions would withstand or survive amidst a disaster while the costs are low. Disaster recovery is based on the key idea of redundancy. Redundancy is the provisioning of extra hardware, extra software, and manpower to help mitigate the threat arising from disasters. Redundancy provides proactive prevention. It means when the disaster is about to strike, it will do some proactive measures to improve the resilience of the network. It would provide backup facilities that would also serve as load balancing features. And in the wake of disaster, redundancy gives reactive recovery. Let's look at this figure. In this figure, we see that we have disaster here. This disaster has a disastrous effect on the network functions, which are mainly the information technology related functions. So we have to allocate redundant resources here. These redundant resources are provisioned to respective IT functions. How much resource or how many resource elements are required to be spent in order to provide a degree of resilience is the question that we are going to address here. First, we look at formal redundancy allocation model as it is actually a way to stepwise or methodically move to allocate the resources for the network by looking at the needs of the organization. Here in this case, the authors define them as IT functions. The IT functions in any organization are generally implemented through hardware, software, communication channels, and human staff. Mathematically, these could be represented in the form of these variables. Here we see a number of variables being defined here. Let's look at them one by one. D is the number of potential disasters plus 1. The one which has been added is for no disaster scenario. P sub D is the probability of disaster occurring. M is the total number of IT functions which the organization needs to perform. W sub M is the importance or the frequency of usage of an IT function. N sub M is the number of solutions which are available to a certain IT function small m to select from. X sub mi is equal to 1 if the solution, one of the solutions I is equal to 1 up to n sub m is selected for IT functions m and it is 0 otherwise. C sub mi is the cost. S sub mi d is the survivability of solution I for IT function m against a disaster of number d. E sub MID is actually the failure probability, which is of course 1 minus the survivability. And B provides us the representation of the budget. Here we look at the redundancy allocation model as a maximization problem in which we try to maximize S superstar, which is given by the double summation of this weight and which is dependent upon 1 minus the product of all the survivability. Now this maximization function is dependent upon certain constraints. The constraint which is shown to you here says that at least one IT solution is selected and allocated to each IT function for providing redundancy. The second constraint is there to guarantee that the total cost of redundancy allocation does not exceed the budget limitation. Finally, this maximization problem gives us a scenario in which we have the resources which are allocated to IT functions, and if a disaster strikes, then either the redundant resources are going to be good enough and the overall network is going to survive, or the otherwise. So M actually fails, M is an IT function, against D only when all of its selected solutions fail at the same time. As long as at least one of the solutions survive, M would be operational.